Okay, this video is going to start about talk about section 3.4, which is contingency tables having to do with probability. A contingency table shows sets of data, and it also helps you calculate probability. If there are total columns, then it's really simple comparatively because you can just get data straight from the tables. If there are total columns and rows, or if they're not, you want to total up your columns and rows, and then getting your probabilities is less complex. So let's look at how this is written. So for A here, it says the probability of someone who uses cell phones. So when it just has A uses cell phones, it's just looking for a total. So uses cell phones while driving, you go over here and we find the total, 305. And then we find that out of the whole total, which would be 755. And typically it's better to turn that into a decimal. So 305 divided by 755 gives us 0.404. So that would be the probability of someone who uses a cell phone while driving. Next question. Probability of no violations in the past year. So no speeding in the last year would be 685 out of 755. 0.907. So if there's just one thing listed, you compare the totals. The next level is probability of no violation and uses a cell phone. So on a table, you just find where those meet. No violation, uses a cell phone, they meet at 280. So that's 280 out of 755. Gives us 0.371. Okay. Now D has us do an OR. So we're going to use the addition rule. So our phone users are 305. Our no violations are 685. But then, because they're not mutually exclusive, we have people that did both, we're going to want to subtract that. So 305 plus 685 minus 280 gives us 710 out of 755. And then when I do that division, I get 0.940. So those are our basics in here with our table. Now let's get into our conditional probabilities. User given violation. So don't forget our given. So on top, we put both our user and violation. So a cell phone user with the violation goes on top. That's 25. On the bottom is the given. So people that have violations. So speeding violations in the last year would be 70. So 25 out of 70 is 0.357. So our givens, just like before, we're limiting that probability, but instead of having to do fraction over a fraction, we can just use the numbers straight from the table. So let's do the last one. No violation, given no phone. So on top, we put both. No phone, no speeding, 405. And then on the bottom, we put no phone. So no phone total is 450. So 405 divided by 450 is 0.9. So that is how you use a contingency table. Pause the video, try the you-try, and then start the video to check your work. Okay, probability of stretches. So your stretches total is 350. Out of the total is 800. 350 out of 800 is 0.0438. Okay. And then for B, we have the vertical line. So stretches given no injury. So on top, we do both. Stretches and no injury. over the no injury total, which is 514. So 295 divided by 514 is 0.574. All right, let's look at another table. So do some more examples. We got a whole bunch going on here. Okay, first we're going to fill in the table. Now, where you're given some totals, anything that needs to fill in, things just add up. So if we have 45 and 55 here, we just need to add those together to get the bottom. So 45 plus 55 is 100. Now to fill in this blank, we're going to do 45 minus 18 minus 16. So that means this has to be 11 for that to fill in. Now 11 plus 14 is 25. To fill this one, we can do 41 minus 16. We get 25. Then for this one, we subtract 55 minus 14 minus 25. That's 16. And then 18 plus 16 is 34. And if we wanted to double check that bottom row, we could do 34 plus 41 plus 25 also equals 100. So we're good. So you fill in the blanks by just adding and subtracting so that everything totals up to the right thing. And then we just do the math. So now, what's the probability of female and coastline? So we find where they meet, 18 out of the total, 100. And 18 hundredths is 18 hundredths. Okay. Now it says probability of female times probability of coastline. So female total is 45 out of 100. Probability of coastline is 34 out of 100. If we multiply those together, 45 times 34 is 1530. 100 times 100 is 10,000. And then 1530 divided by 10,000 is 0.153. And now it's saying, are being female and preferring coastline independent? So if we think way back a couple sections to those, if they were independent, female and coastline would be the same as just multiplying those together. So did we get the same thing when we multiplied female and coastline? So are A and B the same? No, they're not the same, so they're not independent. Okay, let's look at the next one. Probability of male given hiking near lakes and streams. So on top, male and hiking near lakes and streams. So that's this one, 25. Over the given, so over hiking near lakes and streams is 41. 25 divided by 41 is 0.610. Probability of female. So we found that right here. That was 45 over 100, which is 0.45. Probability of mountain. So our mountain total was 25, which is 25 over 100, or 0.25. Female and mountain, that's 11. So 11 out of 100, or 0.11. And then woman, which is the same as female on this chart, or mountain peaks. So our female was 45. Our mountain was 25. And then our and was 11. Don't forget with our or, we have to subtract the double, or that counts in both. So 45 plus 25 minus 11 is 59. Turn that into a decimal, we have 0.59. So that is 3-4. Let me know if you have any questions.